Hello, everyone, and welcome back. And hello, Wim. It's so nice to have you. I'm so happy to introduce you today. Wim is a business architect principal, a trainer, a longtime expert in the world of testing and requirements engineering. And you have a strong focus on the financial sector, which we're going to talk about later today. You're not just a skilled educator, but you're also, among many other things, a co-author, for example, for the ICQB CTFL 4.0. And today, we're super excited to have you here because you will introduce us the concept of test design debt. So I'm very interested to see what that entails. It's a growing challenge many teams face when test cases become bloated, outdated, and unmanageable. So we're really happy to have you here today, Wim, and please welcome Wim. The stage is yours.
Yeah, thank you, Elena. There, my slides are coming up, so I can start my story. Elena already introduced myself, so I can skip that part, so I can immediately dive into sharing a secret with you. And the secret is about the fact that requirements will change. Now, we all know that requirements change. Research has shown that approximately one requirement out of three will change throughout your project. So between the conceptualization phase and the actual delivery, 1 out of 3 requirements will change. And the secret behind this, well, is obviously because business people, they don't know what they want. They cannot make up their minds, so requirements just keep changing. No, this is nonsense. Of course, testers, we complain about the fact that business people don't know what they want. And for certain requirements, this is the case, but there are other reasons why requirements change. Requirements change because business processes change, and thus the requirements have to be updated. Requirements change because your competitors are launching new products. They're doing things in the market, and not to lose market share, the requirements for your products have to change as well. Requirements change because due to changes in legislation, regulation, whatever, and you just have to comply with it. You have to do things differently than planned. Requirements change because business priorities change. You're going to focus on new markets, and thus your requirements have to have an update. Requirements change because of changes in technology. A good example of this is, well, it's happening all around. 2 years ago, nobody was talking about Gen AI. And now everybody is looking at you, what? You're not applying any Gen AI things in your daily job? That seems weird. Requirements change because your users are asking for new features or to change features. Hey, I love your product, but it would be great if you could also do this, or if you could change that interface. And requirements change, well, obviously, because requirements are not perfect and there might be defects in your requirements, and thus they also need to be updated. Now, how do you deal with those changes? There are 3 things that you can do with the changes in your requirements. First of all, you can accept them, meaning that, well, the product we're currently working on, we accept the change in the requirements, and the next or the current release, it has to be implemented. You could also do the opposite. You could reject the change and say, nah, no way, we're not putting this change, this ID in our product. No way, never. Or you could postpone the change. That you say, well, great ID, but not for this iteration or for this release. It's for the next one. Now, the decision to accept, reject, or postpone a change depends on a number of factors. The first one is value. What is the value for your users? What is the value for the organization in having this change? A second one is, what is the cost? How much will it cost us to implement this change? Or, opposite, how much will it cost us if we don't implement this change? You have to look at your timing. How much or how long will it take to implement this change? Do we have enough time before the next release? to actually implement this change. Because if it's taking longer than the foreseen time you have for your release window, you might have to postpone it. You have to look at your resources, your human resources, but also other resources, the people that have to build this thing and the equipment that you need to deliver the changes in that system. And of course, we're all testers, so we also need to look at risk. What is the risk of having this change in your product? And last thing we should look at is, what is the impact of doing this change? What can potentially go wrong? It goes even beyond risk. It is looking at everything. And the impact of changing requirement is, as I said, it is everywhere. Does it also have an impact on your test cases? So the changing requirements, they actually lead to test cases that have to change. And that is often neglected when doing an impact analysis on determining whether to implement a change or not. Now, changing requirement is not the only reason why you need to update your test cases. There are more reasons. The first one is, well, the fact that multiple testers are working on the same test cases. And everybody has their own way of working. And then if you have to align those test cases, there have to be made some modifications. If you're under time pressure, we all know that time pressure is not beneficial for your project. And putting people under time pressure is definitely a guarantee that they will make mistakes. And if you make mistakes, they need to be resolved. Copy-paste errors. You create one test case and you copy-paste and you change what is different. But all of a sudden you get a phone call or a colleague comes, ask you something, and you forget to update the test case completely. And thus there are some things that you didn't change, that you didn't update as needed in your test cases. If you misunderstood the requirement, that means that your test case is wrong, that you're testing the wrong thing. And thus, once more, your test case needs to be updated. If you missed out on certain test conditions, so you did understand the requirements, but you didn't grasp all the test conditions, it means that your test cases are incomplete and require update. And it can happen that you already are aware of the fact that you need to update your test cases and you started with it. And halfway you decide, well, actually, we can do this even better. So let's start over. You're making a big mess, you know. And then new testers come into the team. Again, they have their own opinion, their own insight, their own way of working. They do things differently. And this again leads to required changes in your test cases. And if you're going to migrate to a new test management tool, well, that migration might also be the cause of you having to update your test cases. And all of these reasons all lead to test design debt. Test design debt, in short, you could define this as every time you say, I'll do it better later. Let me give you a more profound definition of test design debt instead of I'll do it better later. Test design debt is the implied cost of having to clean up the mess testers made by documenting tests quick and dirty and not sticking to best practices and design patterns. I don't know if you're familiar with best practices in test case design or in design patterns for test cases, but for me, this has all to do with test case maintainability. Okay, now what is test case maintainability? I'll try to explain it by looking at the maintainability that comes from the ISO 25010 standard. Now, the ISO 25010 might not ring a bell for all of you, but for those who are familiar with the ISTQB curricula, they know that it's a quality standard. It's an ISO standard that describes quality attributes for software products. Now, we're not talking about software products, we're talking about test cases, but I'll explain what maintainability is for software and then make the link to test cases. Now, in the ISO 25010 standard, maintainability has 5 sub-characteristics. And the first one is modularity. Modularity indicates or refers to the fact that developers shouldn't write one big monolithical block of code, but that they should write their code in modules, in small pieces that interact with each other. So that if they have to make changes, if they have to maintain their code, they don't have to look in the entire pile of code, but only in the code of one particular module. Now, if we want to apply the concept of modularity to our test cases, it is recommended that you work or that you create small test cases, short, concise test cases, not the lengthy ones, but short ones. That, of course, also interact with other test cases. A second subpart of maintainability is reusability. Don't redefine the same thing over and over and over again. Define it once and reuse it. Now, for test cases to be reusable, it is recommended that you write them in a more generic way, that you generalize as much as possible, because then it's easier to use the same test case in a different context and it's still applicable. A third aspect for maintainability is analyzability. You should be able to understand what a certain piece of code does. For developers, this means that they have to write command lines, not just escape characters to indicate a command line. They actually have to explain what their code does. And they should also use clear names for their functions and parameters so that you can actually understand what a piece of code does. Now, analyzability for test cases, here it is important that you don't assume. Never assume in any testing that you do. Making assumptions is one of the worst mistakes a tester can make. You have to be sure. And you cannot be sure by yourself. You need to get confirmation from others. In this particular sense, I'm talking about the fact that you shouldn't assume about who will be executing your test. It can be that you're typically designing your tests, you're documenting them, and that you run them, but it can always be that you're put on another project and that one of your colleagues has to run your test. And if you write your test in a language that only you understand, your colleague cannot run these tests and definitely cannot update them because they don't understand. So never assume about who will execute the test. Okay, wrong button, Wim. Next subcharacteristic of maintainability is modifiability. Modifiability refers to the fact that code should be written in such a way that you can make changes to it and that it's not put together with paper clips and chewing gums and some Band-Aid. And yeah, it works, but don't touch it because it might fall apart. That's not the kind of code you will. So code should be written in a well-formed way. Now, your test cases should also be modifiable. And what helps for test cases to be modifiable, that you can update them and that you can change them, is working with a glossary. That you have a fixed set of terms that you use to compose your test cases with. And having this in place will make it easier to do, for instance, a find and replace all. If a certain word changes or a certain feature or functionality changes, you can just, with find and replace all, retrieve that particular functionality within your test cases and easily update it. And another thing that helps is striving for simplicity. Keep in mind the KISS principle. Keep it simple, stupid. Don't go for a difficult solution if there is an easy one. Okay, last aspect of maintainability is testability. You should also be able, of course, to test your code. This typically refers then to the fact that probably some test hooks may have to be added to code to make them testable, or that they should be written in a language that you can still review them. Now, testability of test cases may sound a little bit meta to some of you. It looks like I'm somewhere in the Matrix playing Neo and that I'm looking for a fifth or even sixth dimension. It's not that hard. Test cases can become testable if you have quality criteria for them. Quality criteria that define these are the rules that a test case should follow so that we can call them a good test case. Now, what can you use as quality criteria for test cases? Here I had a look at IREP. IREP, Requirement Engineering Board, they propose a number of quality criteria for requirements. And since you can state that requirements and test cases are more or less the same thing, you can, I'm not opening the discussion here, but since you could say that, you could use the same quality criteria for test cases as for requirements. Now, of course, this is just an example and a concept that I'm offering. You have to decide yourself which quality criteria that you want for your test cases. But things that you can use. First of all, your test cases should be adequate. They should actually describe something that you should test. Next to that, they should be understandable. They should be written in a format that they are understandable by anyone who has to be working with those test cases. Your test cases should be traceable. Now, this is part of any testing handbook. You need to link your test cases to their sources. You need to link the test cases to their execution. You need to link those test cases to the version of the software in which they're being executed. You need to link your test cases to the defects that you detected with those test cases. You need to have this full traceability. That if there are changes, that you can also perform an impact analysis. Test cases should be unambiguous. You don't want those, ambiguous tests that, depending on who is running the test or is performing the test, might get different results. That's something you want to avoid. If there are different options in doing things, then make different test cases. And last but not least, your test cases should be complete. So the test case itself, the description, should tell the whole story of what you're expected that is being tested. And I don't mean the full description of the requirements, but that it's clear what you're expecting from the person who has to run the text, that they don't have to figure things out themselves. Okay. Now, maintainable test cases. Sounds great, but how do you get there? I've been talking about them, and you should avoid test design debt. But how do you actually get to maintainable test cases to overcome or to avoid ever falling into test design debt? Well, let me give you some tips. First of all, do a proper job of testing. That means apply test design techniques. In the ISQB foundation level, you already have some test design techniques, and there are more courses, there are more syllabi that even go more in depth on different test design techniques. They exist for a reason. Use them. Apply static testing. Review your requirements. It's also in every handbook of testing, but we do it too little. Reviewing requirements, getting them already to a higher level of quality will automatically lead to a higher quality of your test cases, and most likely also to less rework of those test cases. Consider coverage. Make sure that every requirement, every user story, every acceptance criterion is covered in at least one test case, and vice versa, that every test case can be linked to a requirement. Don't over-test things. And also a recommendation, use tools. Use tools wisely. Use the right tools to do your test case management. Okay, now these tips, nothing exciting. As said already a couple of times, they are in every test handbook. So this is what you learn in every course on testing. But there are more tips that I can give you. And these actually come from the trenches, from having 18 years of experience within testing. First of all, you need to wonder, do you actually need test cases? It depends on a number of factors. And first of all, you need to wonder, what is actually my test objective? What do I want to get out of testing? Is it just confirmation that things work like they should work, or just confirming that things still work as they should work? What is the objective of testing? That is already one thing you have to keep in mind. A second thing to keep in mind is, what is the lifespan of my test or my product? Will you use or is it something that you're only going to use for a couple of weeks because it's a contest and people can win some goodies from your organization, and afterwards you just discard this website? Or is the new backend the new mainframe of your bank or your insurance company? The lifespan of your test has an impact on whether you should create a test case for it or not. And actually, you don't always need test cases. Sometimes we focus too much on test cases. If you're doing exploratory testing, you work with test charters. And sometimes just having a list of test conditions is also sufficient to test. You don't need to elaborate them in test cases. And what else we can use? Checklists. You can use a checklist to test your system. You don't always need test cases. So that's the first question you should ask yourself. Do I actually need to document this in a test case? Okay. What you see here on the image is Hadrianic Wall. Hadrianic Wall is built by the Romans in Britain to save the British Romans from, or to protect them from the savages in the north. And I use this image because divide and conquer is also a Roman principle. And I thought it would be a nice match to put these two together. Now, divide and conquer, the first thing to do is keep in mind that every test should have a single goal. Don't put too many goals in one test, because if then one of those goals change, it affects the test, all of those tests every time again. So try to keep it concise. Another advice I can give you is separate your navigation script from your actual test. What I used to do was I would create a folder and I would have one test that would describe how to get to a certain screen or how to put your system in a certain state. And that's what I call the navigation script. And all other tests in that particular folder were already having as a precondition that you did those navigation steps. And that would make your test more concise. Then you don't have to elaborate in every test again how to get to that particular step in your process. I already mentioned it. Use preconditions. By determining your preconditions, by documenting your preconditions, all of the steps to get into a certain situation, you don't need to elaborate because it's part of your precondition. And by working with preconditions, you can also put your test in the order of execution, because a previous test can create the preconditions for the next test to run. So important here is that you don't put the execution order in your test, but that you put your tests in the order of execution. And what also helps is to plan up front. Come up with a test design plan. Document, determine with your teammates, how are we going to document your test? And the ideas, the tips that I'm giving here can be part of your test design plan. More tips. And here's Granny. Now, you can look at Granny and we're going to let her rest. But why is Granny in my slide deck? I had some colleagues that used to teach our junior testers, you have to write test cases as if Granny could execute them. Remember that I said don't assume about who will be running your test? Well, let's assume, now we're making a big assumption, that Granny will not run your test. Quite often, Granny doesn't even know how to operate a computer. So why would you expect somebody who doesn't know how to run a computer to run your tests? Don't document your tests as if Granny would execute them, because it's just too much detail that is not needed. So let Granny rest, let her watch Wheel of Fortune or whatever, but don't put her to test. Keep in mind, less is more. Less is more, so group null actions. Sometimes you have to perform a series of steps to get to a certain situation or to do something particular, but there are no expected results. There's nothing particular you need to test for those actions, but you need to perform them in order to test what you do need to test. So all of those tests that have null results that are important, I call them null actions, put them together in a block. Work with parameters. Define a test once, parameterize it, and work with parameters that can be fed through a spreadsheet or whatever, it will make your test case more concise. It will make your test case more maintainable. You only need to update the list of parameters and not the test case itself. Make reference to your data. Don't hard code test data in your test cases. I recommend to just give a link to where to retrieve the right data. You can write the SQL query in your test case that with every time you have to execute the test, you can run the query, fetch fresh data that has not been corrupted, and run a fresh and clean test with fresh and clean test data. And already mentioned, work with checklist. You don't have to put everything in a test case. Checklists are very useful, and we're underusing checklists to test a system. Specialize. We generalize, try to generalize everything as much as possible and specialize where needed. Now, how do we specialize within our test cases? Keep in mind that every test case should be unique. If you have different test cases that are actually covering the same thing, then most likely you should generalize those tests. Use formatting. Any test management tool, and yes, even Excel, allows you to format your test cases. You can put things in bold, you can underline things, you can highlight things, you can put things in italics, work with different colors. But using this formatting will give you, with one blink of an eye, the main concept of a test case. You just see, okay, this is my focus for a test. And the formatting can also help to overcome issues with copy pasting. Because if you, from your basic scenario that you're going to copy, if you dare highlight all the things that have to be updated in every copy, then you see in every copy, for as long as there's still things highlighted, that you missed some things that need an update. So it also helps you to not to forget to change certain things. More things you should consider. Don't put actions in your result. I see it quite often that you do a certain action in your system and that in the result then they say verify in the database. No, because opening the database is actually a different action. In your expected results should only be facts, no actions. And the last one here, also very important, don't use the word or in your test cases. If you can perform an action by clicking on the button or do a right mouse click, actually those are two different tests and document two different tests. Don't leave it up to the tester to choose whatever option they prefer, because it can be that whoever is running or executing the test will always use the button and never use the right mouse button, and you might miss out on defects. So if you have multiple options, multiple test cases. Okay, we're almost through the list of tips that I would like to share with you. The last slide on this is telling you that you have to use a clear language. I already mentioned that you should use a glossary. Define the terms you're going to use in your test case, but also the actions. Are you going to click the button, press the button, or push the button? Use or pick one term and use it consistently in all your test cases. I once had a project where they even had terms like RMC in their glossary for their test cases. RMC, right mouse click. But if everybody uses RMC, more concise test cases. Next to working with a glossary, you should avoid fuzzy terms. Fuzzy terms are very nice in prose, and they just make your text longer. And ChatGPT and Copilot and Bart and all those other tools, they're very good at adding a lot of fuzzy terms to a text, but actually they don't say anything. Do as needed. Okay, but what is needed? So avoid these fuzzy terms because actually they don't say anything. They raise more questions than that they give answers. Other things to focus on is working with a clear title. Your title, it shouldn't go as far as clickbait, but the title should actually summarize what the test is about. So that if you just go through the list with your test cases, you immediately can spot, this is the test case that I need. And the last one, use the numbering that is offered by your test management tool. Don't put the numbering in your titles. I was once on a project where all the test cases were numbered in the title. And if you then had to update or had a new project, then you had to manually change the number 1.1.2.5.3 to 1.1.5.6.7. Yeah, it was a lot of wasted effort and it didn't have any added value. So don't put numbers in your titles. Use the numbering offered by your test management tool. Okay, now let's summarize all the tips that I gave you. First of all, there are some principles you should adhere to. Put your test in order of execution, not the execution order in your test. Keep in mind, one test, one goal. Never, and I'm going to say it once more, never assume. Keep in mind, less is more, and try to generalize. Generalize as much as possible, only specialize what is needed. Okay, so 5 principles. There are also some things that you need to create for your test design. First of all, you should create a test design plan. Together with your colleagues, determine how are we going to draw up our test cases. Next to that, come up with your glossary. How are we going to label the terms we're going to use? Define some quality criteria. This can be part of your definition of ready. This can be somewhere else, but have some quality criteria that are generally applicable for every test case that you're going to create. And create your execution schedule in which you schedule your small test cases. And last thing I would like to recommend you is work with test design patterns, best practices to avoid test design debt. The first one, separate your navigation from your test. Work with preconditions, work with parameters, work with checklists. Make reference to your data instead of hard coding it. Use formatting, that's what it's for. Don't put actions in your results, don't use the word or in your test cases. Avoid fuzzy terms, have a clear title without any numbering, and use test design techniques because that's what they're for. Okay, now you might say, oh, Wim, you've wasted 30 minutes of my time. I can do this better. Well, great. But at least you listened to my story and you thought about it. And if you have a different idea or a different opinion, please share your thoughts with me. I'd love to hear them. What is most important, instead of just following what I said, is that you find the balance. How general or how specialized should your test cases be? In all of the things that I mentioned, you need to find the balance, and you need to do this in agreement with the rest of your team. Sit together and discuss and come up with how your test cases should look like and document this in your test design plan. Now, if you want to dive deeper into this subject, what I can recommend you is something new from ISTQB, and it is the new ISTQB Advanced Level Test Analyst syllabus. It has just been released last month. I happen to be one of the co-authors, and there are also some chapters on test case maintainability. It goes also deeper in a number of test design techniques that will help you to draw up better test cases. Thank you for listening to my story. Please connect on LinkedIn and share me your thoughts on my story.
Thank you so much. I don't think anyone thought you wasted their time because it was so interesting and so hands-on, which I really loved because you gave so many great advice that could really be used, I think. And we prepared a couple of questions that we want to ask you. First one is already shown. So you talked a little bit about testing. What about test automation? How could these tips and tricks be applied to test automation?
Certain of these tips definitely apply for test automation, but test automation goes even beyond these tips. Because for test automation, it's actually writing code. And for code, you already have design patterns. So coding, just to write code, you already have your glossary with your parameters and functions that you have to reuse. So there are some concepts you can use for test automation, but test automation has their own design patterns. I wanted to create some for manual test cases.
Okay, and you talked about like the just test design debt and what that means, but how would you be able to like avoid that when it's not a new project but an ongoing project?
Yeah. You're already looking towards a pile of test cases and a complete mess. And the question is where to start. That's always an issue. I would say look at your most reused test cases, the most important regression tests, your smoke tests, whatever, the ones that you need the most, and already try to update those. Have your test design plan, have your glossary with the team, and just with every passing of through those tests, you update them. And it's step by step that you grow into updating those tests. And for some of those tests, because you're reworking them, you might even decide we don't need it anymore and discard the test. Then you don't always have to keep every test in your pile of test cases.
Okay, so take each problem one step at a time.
Yeah,
Yeah,
exactly.
makes sense. And for yourself, if you would have or could implement just one piece of advice to your project, which one would that be?
Yeah, that's a nice one. My personal preferences goes to the smaller test cases. Try to write your test cases as small as possible with one clear goal, as general as possible, that you can easily reuse it. And then you just put them in the right order of execution.
Okay. Yeah, I think we learned a lot today. Thank you so much for being here. For everyone watching, don't forget to vote because we want to know how you like. Yeah, exactly. For Wim. Just on the A4Q Testing Summit side. And we hopefully see you soon, Wim, because this was super, super interesting.
Thank you.
For everyone else, please stay tuned. There's a whole bunch of other talks that we're going to listen to today. So thank you for being here. It was a pleasure. And I wish you a great day. And everyone else, enjoy the rest of the A4Q Testing Summit.
Bye.
Bye.
Software testers. Move beyond theory and master testing with the AI-powered ISTQB add-on practical tester by A4Q program. The ISTQB add-on practical tester by A4Q equips you with the theoretical skills and practical competence to truly excel. Learn how to apply black box testing like a pro. Estimate accurately, write flawless defect reports, and catch issues early. The ISTQB add-on practical tester by A4Q complements your ISTQB certification by turning knowledge into powerful action. Visit our website and find out more information.